Take a look at this problem. We're told that we have two angles, phi and beta, on a standard coordinate plane, such that we have the cotangent value here, but we're not told what quadrant it's in. We're given a clue about the quadrant. So how are we going to figure this out? Well, let's think about this. What quadrants could this be in if the cotangent is negative? Where are their negative cotangent values? That's in quadrants 2 and quadrants 4. Those are the places where cotangents are negative. Well, where is secant negative? If you remember, secant is related to cosine. It's an inverse relationship, or a reciprocal relationship, I should say. So if secant is negative, that means cosine is also negative. And that means we're on the left side of this unit circle. So which quadrant can it be, 2 or 3? Well, it can't be 4, so it has to be quadrant 2. That's how you figure out this this location of the angle. You're not given it explicitly. We have to just use those two values we're given, cotangent and secant. Likewise, cosecant, where is that thing positive? Well, if cosecant is positive, right, cosecant of beta, that's greater than 0, that means sine of beta is also greater than 0, because those are reciprocals. So we're dealing with something on the top here. And if you look at tangent of beta greater than 0, well, that can only be in quadrant 1. Okay, we know it can't be quadrant 2 because in quadrant 2, tangents are negative. So that's how we use what we've been given in this particular problem, which is a little different than other versions, to figure out what quadrants we're dealing with. Now we can go ahead and get going drawing our triangles. We just had to do a little bit of investigative work at first. So in quadrant 2, that's a triangle like this. And it says the cotangent of that angle right there, phi, is negative 6 over root 13. Now cotangent means adjacent over opposite. So there's root 13, and I have negative 6 over here. So this one's almost done. Use a little Pythagorean theorem, and we can get, well, something for the hypotenuse. What is this? 7, I think. Because we have 36 plus 13 equals 49. Square root of that is 7. Next, we have, what is this? A quadrant 1 angle. Okay, that's fine. We'll draw a quadrant 1 triangle right here. And the cosecant is 5 over root 21. Well, cosecant is the reciprocal of sine. So this is what we're talking about. 5 over root 21. Okay, and you can see sine would be root 21 over 5. That's not what we're, that would be the reciprocal of what we want. So now I'm going to use Pythagorean theorem again to figure out what the lower leg of this triangle is, and that has to be 2, because 2 squared plus 21 equals 5 squared. Okay, so now we're ready to go finding the sine of phi plus beta, which according to our good old sine summation identity is going to be sine of phi cosine of beta plus, since sines can't change signs, cosine of phi sine of beta. Okay, so now we use our red and blue pictures here. Our red ink for the phi coordinate plane, and sine of phi is going to be, let's see, that's going to be radical 13 over 7. Cosine of phi is going to be negative 6 over 7. That's a little simpler. And then the beta angle, cosine of that, is going to be 2/5. That's a nice easy one. And the sine is going to be root 21 over 5. So now you just multiply it all together, and that should have us done here. 35 is going to be the denominator. On top we have 2 radical 13 on the left, and on the right we have minus 6 radical 21. And it looks like this is not going to be simplified at all. There's no radicals that have anything that can drop out. It's all prime numbers and factors of prime numbers. So we are done at this point.